So here's our project cash flow. Lasts for 4 years. At time 0, there's investment, there's cost of $10,000. Year 1, 4,000 benefit. Year 2, 6,000 benefit. Year 3, 3,000 benefit. Year 4, $4,000 benefits. Now we want to calculate the internal rate of return of this project. So what is IRR? IRR is the discount rate that make NPV equal to 0, or that make the present value of benefits equal to present value of costs. And we can use an Excel function, IRR. So data, the input data, which is B3, from B3 to F3. And we can guess an IRR, or we can just leave it empty. And it's 26%, or let's say they have more digit, 2 digit, 26.24%. So the IRR is 26.24%. And you compare this IRR with the cost of capital. For example, to finance this project, you borrow from bank, and the bank charge you a loan rate of 10%. So now 26.24% is higher than 10%. Then you conclude that this project is good, it's efficient. One problem with IRR is that we can have more than one solutions, one levels IRR. So let's look at these examples. So this project lasts for 2 years. So initially there's cash outflow of $14,545, and then there's a cash inflow of $34,182, and at the end of year 2 there's a $20,000 cash outflows. So what is IRR associated with this project? So let's use R to denote IRR. So IRR is make the NPV equal to 0, right? So is the NPV, associate NPV, or is my FR here? So is equal to this discounts or year 1 cash flow and year 2 cash flow back. So it's 34,182 times 1 plus R raised to the power negative 1, okay, plus negative 2,000, 20,000 raised times 1 plus R raised to the power negative 2, plus negative 14,545, and that's equal to 0. So we want to solve for this this actually is quadratic functions. Okay, rather than solve this, let's visualize. So now let's call this f. Okay, it's a function r. Let's draw, let's visualize. So now this this NPV, this f, is a function of r. So let's visualize this. So in order to do so, I'm gonna say if r is equal to 1%, what's associate fr? So fr is just b5 discounted back and b6 discounted back plus b4, which is already present value. And so that's if let me use this. If discount rate is 1%, then associate NPV is $307.36. Similarly, if it's 2%, then it's this. So on and so forth until let's say 1. I can keep drawing, say 1.1, whatever, you know. So I got a set of data. Using this data points, I can draw the function, the graph of the function. So select the data, go to insert, and the scatter plot here. So we can see that, or maybe this rather than draw 1, let me draw a number this until 0.8. we can see that 1.8 and 0.5. Then on this graph, we can easily see that now there's two solutions. One is here, one is here. Okay, one is, oops. Okay. So one is roughly 0.1, the other is like 0.25. So in such cases, we run into problems. We don't know which level of IRR should we use.